Hello everybody and welcome to another day of CS202. Today we're not live streaming, we're actually just recording it, since technically speaking we would have live streamed on Labor Day, so you guys have to enjoy the day off. So here we are. So I will not be turning on my camera today. So today we're going to keep talking about classes and also throw in there the concept of static variables in classes and maybe a refresher on how they work in functions. And then from there, we're going to jump into inheritance and aggregation and composition and how private and public go into play when you do inheritance and how protected variables come into play to solve some of the issues that we're going to face on private and protected. So, and private, public, and protected. So, we may not get through everything, but we'll get through most of it. So let us go ahead and jump in by first refreshing what we talked about last time about classes. So some terminology to refresh is that this is a class, and the class is basically, the class declaration is going to be this line right here. It says class triangle, and then this whole thing is the class definition. And now when you create an object, well, not that all the way there, all the way here technically. And then when you create an object of this class, that's when you're instantiating the class. And so an object of class triangle is going to contain each of these variables. So it's going to contain 2 integers and 1 string. And it's every instance of the class, or every object of this class, will have its own copy of HL and color. So if you have 2 triangles, they each have their own dimensions and color essentially. And another thing is, when you instantiate a class, which is when you first create an object of this class, what happens is a constructor runs. So there's a function, a special function that is neither valid returning nor void, called the constructor. And it automatically runs when the object first goes into scope, which is when you basically create an instance of it, or when you declare the object. In this case, that would be this line of code. Now, the constructor's job is basically to run this little function that can do things that should happen when the object is first created. The most commonly used basically strategy for this is to throw in there all your variable initialization. So in this case, let's go ahead and initialize what the height and the length and the color of the triangle is. And so you pass parameters as if you were calling a function on the object, because the object here is t, so it looks like a function. And it technically is, but really what you're doing is you're declaring an object. You're not just calling any random function. And in this case, you have to look at the parameter order here to make it match just like in any other function. However, here we're using default parameters, which is why you see this syntax here. And that is basically us, initializing the dimensions of the triangle. It's a very, very useful thing to do, because otherwise we would have to use our accessor and mutators to modify things after the fact. It's more code. And so going into that, how would we modify things if we wanted after the fact? Well, here all the variables are private, meaning that you cannot access them directly outside the class. So if I wanted to modify the height or the h of the triangle, I can't just go ahead and say t.h equals 20. I have to use the accessor functions to read the data, or if I want to modify it, I have to use the setters or mutators. So for example, if I wanted to set h to be a specific value, I have to call the function setH. And this function takes a parameter, and that parameter is typically going to be what you're trying to set. So in this case, it's height. And as you can see, the function is very, very tiny. All you're basically doing is you're assigning the height to be h. So you might be asking yourself, why go through this effort? Why not just make the variable accessible like it is with a struct, or like it would be if I put the public modifier in front of it? And the answer is because when you make it private, you don't necessarily just have to make your setter be just one line of code. You could put a bunch of if statements to check for potential invalid values, such as a negative height or other things, which is kind of what we were sort of doing when we did for the length. So I said that the length is less than 1, you go ahead and see out that it's an invalid length. Otherwise, you go ahead and you assign it, right? So we did the check for this one, but we didn't do it for this one because I just wanted to give an example but not spend too long. So ideally, your setter functions will be more than just one line, because they will be potentially doing any kind of error checking, and that's a very useful thing to do. On the other hand, when you do make things private, you can't just access them directly, and that's what we use the accessors or getters for. The getters is typically value returning functions, and the type of the return is going to be typically the type of the variable that they're trying to access. So in this case, it's integer. And basically, it's just going to be a return and then the variable, because usually you don't need to do anything to it. I mean, if for some reason you wanted to return something different than what is stored there, I guess you could do that, but that's not usually the case. You do see the word const here. What that means is you're basically making this a read-only function, and that's a good idea because it's only an accessor function. It shouldn't change anything in the class by accident, and that sort of protects you from doing that. Similarly, for the setters, the parameter we're passing here is being passed by reference, but I'm putting a const in front of it, which helps me avoid accidentally changing that parameter value, because by passing my reference, I risk changing it by accident. And so that's a little bit of a refresher on getters and setters. Now, going back to the constructor, as you can see, we are doing the same thing, but it's good to do here because we're initializing it. I want to talk about this syntax here. So one way that you initialize variables in a constructor is in the body of the code, which starts here and ends here. You can go ahead and basically just say like color gets C, and C is a parameter that's passed in here, right? And you can do some sort of error checking or special things in here. The other way that you can more directly initialize class variables in your class is using this little method here. This method here is putting in a colon, and then it's putting in the variable name, and then in the parentheses is putting in the parameter that you want to initialize the variable with. So it looks like you're calling a function in a way. You're saying L length, and length is this parameter here. But what you're really doing is you're initializing the value of L with the contents of length. And it is an alternate way of initializing variables, which is going to come very, very useful when we talk about inheritance, because you can call the parent class constructors that way, which again will make sense once we talk about inheritance. But I wanted to bring it up for those of you that might be aware of what that is already. On the other hand, when this object finally runs its course and it has to go out of scope, and by that I'm saying when you are basically done with that object and it is the end of main and this object no longer exists, or if this was any other function, at the end of the function it's no longer existing, so the computer, the operating system, is going to basically throw this away. And when it throws it away, it calls what is a destructor. So when it first gets created, it calls the constructor, and when it's time to destroy it per se or throw it away, it calls a destructor. Now in this case, the destructor doesn't really do anything except say goodbye. This will come more into play when we talk about dynamic memory allocation, and that's where you can do your memory deallocation to avoid memory leak. So we'll definitely revisit the destructor and find more useful usages of it than just simply saying something like goodbye. And so this kind of concludes where we kind of stopped the discussion last class. And so I want to build on this now by first talking about static variables, and then from there we can go ahead and sort of do inheritance. So static variables, okay? So right now, as I said, if I was to create a triangle object here, T, it's going to have its own copy of color H and L. It also has its own set of functions, but all the functions are shared. So the operating system, or yeah, I guess the compiler, the compiler makes it more efficient by not copying the code of each function into each object. It just has one reference of it in code. Basically, it has one copy of it in code, and then each of the objects has a reference to get there. And that's called compile time binding, and that is going to cause some issues that will require us to use runtime binding, which will be virtual functions, which will be later down the line. After I think we first have to talk about pointers, and then we go virtuals. So yeah, it'll be a while for now. But basically, in short, while each object has its own copy of variables, you know, each triangle has a color, each triangle has a height, and each triangle has a length. They're not shared. They do technically share the function code, and they just have a reference to the function. So there's only one copy in the entire code for the program that the compiler basically builds. There's only one copy to this perimeter function, and then each of these objects just has a little pointer per se that points to this function. Okay, that's kind of the oversimplification of that. Okay, again, we'll revisit that more when we talk about compile time versus runtime binding and virtual functions. Okay, so what if you wanted to share a variable that all classes had one? So imagine that you wanted to have, say, another variable here, another integer that we called int x. And you wanted that variable to be shared amongst all triangles, meaning that there's really only one instance or one copy of that variable in memory, and they all share it. So rather than having basically their own length and their own height and their own color, this is going to be sort of like the communal variable, okay, the parties variable that's shared amongst everybody, okay? And so that's what static functions are going to be useful for. And so let us go ahead and show that by example. So I went ahead and created a new file here that, remember, I always upload these at the end. And we're just going to make a class called A. And this class A is going to have, it's going to have everything be public so that we don't have to worry too much about accessors and setters for now. And it's going to have an integer X and an integer Y, okay? And that's pretty much what our entire class is going to be. So let us go ahead and create two objects of this class to make sure that we understand how each one has their own copy. So we're going to call them A, and then we're going to call them maybe A1 and A2. I was going to call one A and B, but that's kind of weird. So A1 and A2. There is no constructor in this class, by the way. However, every class in C++ has a constructor by default. That is known as a default constructor. You're always given a constructor by the compiler, okay? So, yes. In this case, the constructor does really nothing, but, you know, if we wanted to have a constructor, we could add one. You know, we could say something like A, and then maybe say X is going to always get initialized to 0, and then maybe Y gets initialized to 4, okay? And that's it. There's not really any code in the body because we did all the initialization there. So, you know, I guess we can add something. We don't have to, but I'm going to say a constructor, okay? Just so we know that it actually ran. Same with the destructor. We're given more by default. We're not going to add one in. We could, but we're not, okay? So right now, you know, if I say AX gets 2, and then I don't do anything maybe to A2, and I go ahead and see out A1X followed by A2X, I forgot to check what time I started recording, so I was looking at the clock to make sure that. Okay, so all right, that way I don't do like a 5-hour lecture by accident. Because I can lose track of time pretty quickly here. So yeah, okay, so you know, if I run this, I can see that the two X's are different. One has 2, the other one has 0, right? And that's because we left it with the initialized value. We can of course update it and set it to like, I don't know, 8. And then if we run it again, this should say it to 8, right? Okay, good. So what I want to do now is I want to have some sort of communal variable. I want to have a variable that is shared, okay? So let's go ahead and convert Y into the sort of the shared variable, okay? So what I want to do is I want to have a variable that is shared amongst all members of a class, okay? And the way that I can achieve that is by adding the word static in front of it. So I believe actually both will work. I think you can add it here, or you can also add it here. So how about we just make 2 static variables so that I show both methods? I believe last time I checked it worked with both ways, but you know, I might be confusing with something else. Okay, great. So now, first of all, let's get rid of this and I'll explain why in a minute. And bam, it compiles, okay? So now, let me go ahead and prove to you that these static variables are shared, okay? So let us go ahead and modify the A1's Y and set this to 10, okay? And then let us modify the A2Y and set it to 20. If they were individual variables, if I go ahead and copy this, line and convert it into Y's, you know, if it was not static, then I would expect them to be different. In fact, here, let me just get rid of this for a second just to prove that again. I get 10 and 20, right? But now I'm going to throw in the word static. And what's going to happen is you're going to see that both of them are, whoa, a defined reference to a Y. Ooh, okay, interesting. It might be because I haven't initialized it. Let me just try it here and see if I get the same error. A1I, A2I. Okay, so that's probably because I didn't initialize it. So let me go ahead and initialize the variable. So let me just do it first and I'll explain. So if I remember correctly, it's int a y equal to 0, like that. I don't think I have to have the word static at that point. Okay, there we go. So, all right. So what happened is this was missing. So I declared this variable static, okay? But when you declare a static variable, you are forced to initialize it, okay? Like you have to initialize it. You have no choice. You're like forced to do so. And in this case, I didn't, and so it was complaining. But then you might be saying, well, you haven't initialized z. Well, it turns out that you don't run into problems until you try to use it, okay? Then otherwise it'll complain. So that's why it hasn't complained about z. However, I want to see if it does complain if I do it this way. Let's see if that line of code will complain. Ah, so that doesn't complain. Cool. All right, because yeah, okay. So I'll explain it in a second. So okay, so in this case, you can see now that it got converted from basically saying up here. Yeah, can I scroll up? 1020 here, from 1020 when it was not static to now being 2020. So even though here I am referring to a y as thinking like y is part of a1 object, and then this a2y is part of the a2 object, they're not. It's a static variable, so it's shared. So when you change it in one, it changes it for everybody. So in here, because the last change I did was to make it 20, it changed not just a2y, but it changed all of them. Because again, there's only one copy of it in memory. And all you have are a bunch of references to that one copy. So it's basically a shared variable. Now, when would you want to use a shared variable? Well, it's situational. You know, you typically want each object to have their own variables. But the time that I have personally used it is as a counter, because I can use it as a counter to see how many objects of a class I've made. Because what I can do is I can, in the constructor, I can increase the value of my static variable. So here, let's use the z for this one. So in this case, let us go ahead and first of all, so this is complain, let me initialize it. And again, I haven't talked about how this initialization works, but you know, just let me do it for now. We'll initialize that one to 0 too. And so what I can do is in the constructor here, I can increase it, okay? So every time that I make an object, z is gonna go up. So now z should better be renamed to as a count, the number of a objects. That's basically what it's holding. So if I go ahead and see out, let's leave this line for now. But if I go ahead and see out it like this, a1.z, and then I go ahead and here, just copy paste that faster. You will see that this is both going to contain the number 2 in it. And that's because it's keeping track of how many objects I make. If I go ahead and make another object here, let's call this one like a3, then now that's going to have 3 because it is containing how many objects I made. So that can be very useful because like if I go ahead and maybe make another variable here called id, that one is not a static variable. I can go ahead and say something like id gets z++. And so now each of the variables is going to contain an ID that's unique to the variable, that is not repeated. And it can be a useful thing to kind of keep track of the number of variables you made. And I personally use it a lot in the assignments that I'm making because it's kind of nice to keep track of each individual object with a name in a way. And that's kind of their names. So as you can see, 0, 1, 2. So each of these has a unique ID. And then Z itself is going to have, in this case, 3, 3. Yeah. Okay. If you wanted the IDs to start from 1, you can just switch the C++ to like ++Z, probably. In case you don't want to. But we're computer scientists. We start things from 0, right? Oh, yeah. But if you really wanted to, you could do that. So, yeah. Oh. I was checking. I have like a sore tooth. Okay, that's weird. So, anyways, going back to statics, let's look more about this syntactic sugar, basically, and what this is. So, You declare a variable static by putting the static keyword, and we understand now what static does, which is a communal variable. But here's the thing about static variables. Because they're shared, they have to be allocated and initialized when the program runs at first time. So like, even if I don't even make an object of A. So like, if I just go ahead and like comment this whole thing out, all the code that we have so far, like that. If I comment all the code that I have so far, and I go ahead and put this line of code and I put a C out here, you will see that that variable exists. It exists in memory. And it has a 0 in it because that's what I initialized it with. Basically, static variables always exist. Whereas non-static variables, class variables, static class variables, or even any static variable technically, I suppose. But any static variable exists at the first time you run your program. There, it is always allocated. It's kind of like a global variable in a way because it's always there. Well, even the global variable wouldn't always be there unless you declare it as the first line of the code. You can think of this as all being on the first line of code. Like literally up here, we are declaring this Y and Z. And that's just by design how it works. So because of that, you need to have an initialize. You have to initialize it as in compile time, basically. So you have to set it to something. And so that's why it's requesting me to initialize it. Now, how do I initialize a static variable? It turns out that I don't think it lets you initialize it inside the class. It might in like the future C++ versions, but I don't think in this current version it does, in like 11. So it forces you to initialize it outside the class. And so because of that, you have to do this on a code. Even if the variable was private, it would still work. And this almost looks like a local, like a global variable sort of modification, and it kind of is in a way. And the syntax for this is you put the data type of the static variable, and then you put the class name, kind of like if you were declaring a function out to the class. So like suppose that I did a getter function for like x, so I did like a get x, right? You know, if I wanted to declare that function out to the class, as a reminder, what you do is you put the return type, then you put the class name, the scope resolution operator, then you put the function name, and then you put the list of parameters, and then you put the body of the function, which in this case would just be return x. Okay? So that's kind of the same thing you're doing when you're accessing static variables, but instead of putting a function name, you're putting the variable name, the static variable name, and then you just initialize it. And as you can see, this is the same code for both static variables with the exception of the name of the variable. And so once you do that, it also brings a little dynamic here because you might be looking at this and kind of scratching your head for a second. So a static variable can be accessed in two different ways. One of the ways is you can access it on an object. So like any specific object you make, so now if we go back to actually having this code, if I go ahead and make 3 objects of A, any of them can be used to access the static variable, such as I did here with like a1.y or a1.z. So I can access that static variable technically in this one in 3 ways. I can access it with A1, A2, and A3, right? So I can access them in any of those. The other way is that because a static variable is not associated to a specific object, it's associated to the class as a whole, you can also just access it with the class name directly. So I can do something like A, scope resolution operator, and Z, okay? The only one that I don't think works, but I want to try it anyways, is this one. I don't think you can use the member access operator, but let me just check. Yeah, you can use it, okay. So you can either use the member access operator, the dot, with a specific object, or you can use it with the class name. Now, it's important to understand that if you try to do something like a scope resolution x, that's inherently wrong. Why? Because x is not a static variable. X is a class variable, which means it's associated to a specific object because each object has its own instance of x, right? Every time you make an A, so A1, A2, A3, they all have their own x because x is just a class variable. And so this, you should be asking yourself, whose x am I trying to access? A1, A2, or A3? So that is why you don't access class variables this way, because it's ambiguous. It's basically telling the compiler who is that x belong to? Who does that x belong to? Which class? I mean, no, it's class A, but which object of class A does it belong to? Okay? And the error you get is invalid use of non-static data member. Okay? So that's, if you ever see that error, it's because you're trying to do something like this. It works for static variables because it doesn't matter whose object you're accessing, because it's a communal variable, so anybody can access it. It's just stored somewhere in memory, and that somewhere is actually accessed using the class name. So Very important to understand that. So that's kind of the whole, that's pretty much the whole thing that you need to know about static variables in terms of classes. In 326, they'll talk more about it, you know, because like, for example, there's also static functions and other kind of fancy things. So it is not the last time you see static variables. Very quickly, because you may not have seen static functions in CS 135. There is such a thing as a static function, but also, more importantly, something that you will see in the assignments that I want to cover is static variables inside of functions, okay? So normally, if I have a function like foo, and I create a variable x, you know, I set it to 5, that means that every time I call foo, there is a new instance of x in that function call, right? And so if I call foo twice, those two x's are separate and independent. I can also create a variable, a static variable inside a function. And in this case, what happens is there's only one instance of it. So no matter how many times I called foo, there's only one y. So if I have like the following code that says x++, and maybe cout x, and then over here I have y++, and then I cout y, no matter how many times I run this function, I am always going to get x to be equal to 6 because I increase it. And on this one, no matter how many times I run the function, I'm going to always have y. No matter how many times I run this function, it's always going to be different because every time I run it, it's going to be bigger. So first time I run it, I'm going to see y is going to be 1. And then the second time is going to be 2. And then the third time is going to be 3, and so on. It's always going to change because it's going to have sort of a memory between function calls. A lot of the times when we do get to recursion, people like to use static variables to help solve recursion. It's not a good idea. It kind of defeats the purpose of recursion and that recursive thinking. So don't do that. But do know that that is, I guess, one way, a bad way, of trying to make things recursive. So let me just very briefly show you the foo call. So let's go ahead and call foo maybe just a couple of times, just so you can see how it changes. There we go, 4 times. So as you can see here, you know, x is always being 6. So we got 6, 6, 6, 6. However, y is 1, 2, 3, and 4. So it's always going up. So it's remembering. So when can this be useful? Other than like weird recursion things. It can be useful to remember or to keep track of, for debugging purposes, how many times you have called a function. Could be useful for that kind of thing. Other than that, I'm not really sure about right now what you could use it for. Okay, so I do bring this up because I think I did use it at some point in one of the assignments that I did. So might as well make sure that we're all on the same page. I don't know, it might have been in the summer, but whatever. It's knowledge. It's good for you. Okay, so that concludes static variables. Okay, so let us go back into classes. But for that, we're going into the iPad mode. Okay, so right now, you basically learned the basics of object-oriented programming. I mean, you know what a class is. A class is basically made up of data, or an object per se is basically made up of data and then operations on the data. So like a triangle, the data is the dimensions and the operations are the measurements, like area, perimeter. But anything can be represented as an object with enough creativity, you know. If you think of a person, right? You know, a person has specific information that you want to keep on them, like their age, their height, their weight, their measurements of like clothing and that kind of thing. Maybe a string variable that keeps their name and that kind of thing. So you can represent a person as an object. And then the operations on the data could be something like get older, which is, or like have a birthday, which increases your age by 1, or name change, if you want to have a name change, you know, so it changes your name. But you keep those names as variables as private to avoid anyone from accidentally changing your name when you haven't legally changed your name, right? I guess if somebody's calling you a nickname, they can't anymore. That kind of thing, right? Or what other things do you have in that class? Well, let us say that somebody's born. So that's going to be kind of like the constructor of the class. So you want to initialize everything to 0 for like their age, and probably their name is like null at that point or something, I don't know. And then their height is like a specific size for a baby or something. Or maybe you have a grow function that is like grow 1 inch or something. So you can have a lot of things basically represented as a class. pretty much anything you can think of. And that's why it's so popular in the development world to do this concept of object-oriented programming. But there's another part of it that makes it even more popular. Because here's the thing. Once you set up this amazing object, you love it. It's like the best object of your life. It's like this amazing thing that you're representing data that you're working with, and you got all these great functions in it and everything. It's like the best thing ever. But then, somebody comes, your boss or someone comes to you and says like, wouldn't it be great if you could add this one more thing to it? So like, here you got your human class, and somebody's like, wouldn't it be great if we could add a string in there called add ID to this class so that we can like keep track of this person's add ID to like sell him stuff, because again, you're representing humans for like a sales program or something. And then you're sort of faced with this situation of like, do you modify your current code, but then what happens to people that like want to keep a version that doesn't have that for like backwards compatibility or something? Or do you just copy and paste the entire code into another class, change the class name from like human to like human version V, and then maybe like put in the extra string in there or something? Like that kind of really brings up into a question as to how do you upgrade this class in the most easiest way? Well, as I said, one of the things you can do is you can copy paste your code and be good to go. But guess what? Tomorrow you find a bug in the human class and you fix it. But guess what? Now you got to fix it in the same spot in two different. The same bug you got to fix in two different pieces of code. One for the human and then for the human upgraded. And so it's a little harder to maintain code when you got duplicates of it, and you gotta apply the duplicate to each one. It's kind of like if you have a recall for cars, and now you gotta bring all the cars back in to update each individual one, right? Because they're basically all independent of each other. So really, it would be nice if you could just keep it like a reference to the original human, and then just make an upgraded human that references everything from the original human, but then you add extra stuff to it, like the add ID or whatever. And so that kind of introduces us into the concept of inheritance. Now, inheritance as a term can be a little bit tricky because typically when we think of inheritance, we think of like somebody dying and then like their next of kin inheriting their traits, right? We think of more of like, if somebody dies, they transmit your traits to the person, or in this case, money or whatever it is, to the next of kin, right? But here's the thing. Inheritance in programming it's not really like somebody dies and just transfers it and that's it. It's more of like referencing it. So, because also another thing you might be like, oh, you inherited your dad's like green eyes, or your mom's like, I don't know. What can you inherit? Fingernail type. Yeah, you inherited your mom's fingernail type. Okay, so you could say something like that. That's a little bit more like this, because then you still have the original one living and you can use it as much as you want, but then you also have the inherited one. But really, I want you to think of inheritance as more of like referencing. Okay, more of referencing a parent. Because here's the thing. If you inherit from your mom green eyes, and then like all of a sudden she gets exposed to radiation or something, and like her eyes become blue or something, in C++, if that happens, your eyes will turn blue as well, even though you're not there. You're like connected to them, right? But in the real world, that wouldn't happen. I mean, they would just turn blue, and then you should still be the original green, right? So that's why inheritance is not really quite the same in programming than when you think about it in real life. Because here there's an active connection. Okay, there's a direct link between you and who you inherited from, and that link means that if something happens here and you inherit it from that, it will update to you as well. And we want this to happen because here's the thing: if there's a bug, if your mom's an Android at this point, okay, that was not weird. Your mom's an Android, and she has a bug. She has like she has a bug that is called I don't know, asthma or something. Okay, we're gonna fix the asthma. So to do that, we're giving a patch upgrade for her lungs to improve efficiency of lung usage or something. Okay, if you inherited your mom's lungs, you want that patch to be applied to you as well, right? So if you fix it here, then it's going to fix it down in the inherited class, okay? So that's kind of the concept of inheritance. It's the idea that once you make a class that we're going to call the parent class, then you can go ahead and you inherit, and typically you draw the arrows this way to the derived class, or in this case, another term is the child class, okay? So when you're inheriting, you know, rather than, you might be thinking when you inherit, you typically say you draw from the parent to the child. Not really. You typically draw it the other way around. You draw it from the child to the parent, because again, it's more of referencing than inheriting, really. Okay, and that's good. That's what we want, because we want to be able to update things here and then apply to any of the inherited classes. Okay, so first, let me go ahead and tell you some terminology for inheritance. There's 3 of them that I want to talk about. You already seen one of them. So in one of them we have a parent class, and then that brings it to a child class. But again, if you're going to draw the arrows, you know, you would typically draw them this way like that, but you would typically see them like this in the UML diagram, because we're saying the child mostly references the parent. Okay, that's kind of what it is. The other one that you can also use is you have something that's and again, these are all interchangeable terms, but I want to cover all of them in case you run into one of them and you don't get confused. We also have superclass and subclass. And so again, that basically means the same thing. In this case, the parent is the superclass and the subclass is the child. So super being kind of like the original, the highest one, and then from there getting like the subs, the minions per se or whatever. And finally, the other one that you see me used as well is base and derived. This one's a little more technical, I suppose. You have the base class, which again is the parent class. These all 3 mean the same thing. And then these all mean the same thing. Okay? So you could use any of them. I mean, you could even use them interchangeably and people would understand you. I would not recommend that. I will try to use them all over the place because I want to familiarize you with all of them. But just pick one of them and commit to it. I typically like parent and child, or sometimes base and derived. I don't really use super and subclass, but some people love and abide by that. I think the Java people like it more. But yeah, they all mean the same thing. We have the original class, the OG per se, being on the left side, and then the derived child or subclass being on the right side. Okay, so let us do a quick example of something, and then we will go ahead and implement it, okay? So suppose that we are going to have a car, okay? And first, we're going to make the superclass is going to be just a regular car, you know, with wheels and speed. And then maybe we're going to upgrade that car and maybe add an electric motor to it, or ABS brakes or something, okay? And we'll do something like that. Because here's the thing. It doesn't just stop at parent and child. Nothing stops you from having like a grandchild class or something. You don't really use that term, grandchild. You would just say the child's class of the child, I suppose. But, or I mean, you could also say like the subclass or like the derived class. I don't think I've ever heard anybody say that. But again, you can definitely have inheritance go on beyond 2 levels. You can have it go as much as you want. And guess what? I'll talk about this probably next time, but in C++, you can also have multiple inheritance. And what that means is kind of like a family, actually. But kind of and not kind of, because normally, biology 101, I suppose, when your parents had you, you know, when 2 people come together and have a kid, what ends up happening is half the DNA comes from the mom and half comes from the dad. It's not exactly split, but it's around them. And so basically, in this case, it's more of like it's kind of RNG what part comes from your dad and mom for the most part. Here, it's more of like you're getting all of your dad and all of your mom when you're making a multiple inherited class. That can cause some issues, just like it would in a real person, technically, because when you're getting 2 color, let's say you have a variable called eyes. You know, this might be a good example to do when we do multiple inheritance. Actually, let's say that you get a variable called eye, and that's a string variable, and it has different colors of the eyes. And your dad has brown eyes, and your mom has green eyes, and you inherit both of them. And so you basically check what the value of the variable of the inherited class is, what color of eyes. But guess what? You have two copies of the same variable. So which is the right one? Are you going to run into problems? And yes, you will. So technically speaking, multiple inheritance can be very risky and is not recommended when there's when they share the same thing. Now, then again, technically speaking, why would you do that in the first place? Well, you know, it gets kind of tricky there. So we'll talk about it. But first, let's talk about something simple, just like inheritance from one parent only. Okay, so that's only like, you know, like a spider or whatever, those animals that only have one. I'm gonna get in trouble for the terminology, but like they have one gender or whatever. You know, like I think spiders, like there's no male and female. There's only one type. They have this. There's a technical name that I forgot. Sorry, but you know what I'm talking about. So you know, there's certain species of animals or just living things that only have one type. A good example is actually probably cells. Small, like not just cells, but bacteria. There's no male and female bacteria. There's only like just bacteria, and then they just multiply, right? You can kind of think of that like inheritance a little bit, but again, it's difficult to try to explain the real world encoding. I mean, that's a challenge of its own, right? So, but still, I'd say object-oriented programming is far better than any other approach out there, and there are others like functional programming and things like that. So, anyways, going back to this. Let us go ahead and stick with the car example, because then we don't get into trouble with biology and programming. So, yes. So let's say we're going to make a class called car. You know, how about we just start coding it? That way we don't have to copy and paste the code later. It'll make it a little more efficient. So let us go ahead and just do it under the more class 2. We can leave that one alone. Let me make sure it still compiles. It does. Good, good. Okay, so I'm getting a little bit what do you call it, dry, like my voice is going a little bit for some reason. I am recording this at almost 1 in the morning, but I wanted to wait until it's not officially Labor Day so that I can technically work. So yeah, okay, so class car. So normally if I was streaming, I'd ask you guys what kind of things you want the car to have, but unfortunately, nobody's watching right now. I'm sure you're all watching, but you're on YouTube at this point. So how about I just go ahead and pick a couple of things, like, and for ease of use, you typically would want to make it private, but to make things easier since it's not kind of what we're trying to get to yet, we'll make everything public, okay? So let's go ahead and say the car has a color. That's a good one. Maybe it has a top speed. Now this could be a double, but we'll make it an integer. We'll just say whole numbers. And then what else could a car have? Top speed, horsepower. No, horsepower is not a good one, because I want to make an electric car eventually, and I don't think horsepower is really. They don't really talk about horsepower in electric cars. What could be a good thing for a car to have? I mean, I know they have like a wheel, but I'm saying things that are measurable that we can add and remove. So like number of tires. I guess I could put number of tires. Yeah. Because that could be like one of those pickup trucks that have like 6 tires, you know? I'm sure you've seen them out there. So I think that'll be good for now. Okay. So, you know, we have this great class, and they might have some functions with it, such as oh, current speed. That's a good one. Yeah, that's a good one. So let's actually add one private variable. Let's make one private variable that says basically current speed. And we want to initialize it to 0, because whenever we first create a car, cars aren't born driving. They're born in a factory and they're not moving. So we'll go ahead and set the current speed to be 0. Okay. So from there, we can go ahead and test the class. Yeah, let's test the class. I always forget the semicolon, but this time I didn't. I'm proud. So we're gonna say the car is called Toyota, because I think that was my first car was a Toyota. So not that I'm trying to advertise. Please don't complain and say I'm trying to sell you cars or something now. But the car was very nice. So great, it works. I created it. I mean, nothing really happened. I mean, we could put in the constructor something like broom. So like when the car gets made, it like makes a noise. So there you go. Okay, so now we're gonna add a function here that's gonna be called accelerate. And we're gonna pass it a speed. So it'll be an integer for speed. And that's how much we're accelerating by. But we want to make sure we don't violate, this car has a governor. And so we want to make sure it doesn't violate the top speed. So we want to check the current speed and say if the current speed plus the speed that we're trying to get is greater than top speed, then just go ahead and set the current speed to top speed. That way we don't go over the speed limit. Well, I mean not the speed limit, the governor of the car. So yes. Also, maybe we do another check here saying if speed I was thinking of checking because it could be a decelerate. So we'll just say that accelerate cannot be called for deceleration. We could do that too. We just want to make sure we check that the deceleration, that the number is no less than 0. We can do something like that. We can say something like if, yeah, I guess we'll do it. Now you can use the same function for accelerate and decelerate is less than 0. Then set it to 0. That way, you know, nobody tries to decelerate a car that's going at 5 miles minus 10 and ends up with like -5 miles going backwards. Actually, that wouldn't be too bad because technically your car could go backwards, right? But that, we'll set it like that, okay? Alternatively, we can just ignore that and have a function called break or something. But again, that's not the purpose of the example. So, okay. Declaration of accelerate, no. Oh, void accelerate. Okay, so let's go ahead and just test to see if the accelerate works. So let's go ahead and accelerate by 88 miles per hour because we're about to travel in time. So maybe we should have made it a DeLorean. How do we make it a DeLorean then? Oh wait, no. Ooh, that gives me the idea. Yeah, okay. Car Toyota, Toyota, not Toyota, accelerate here. So Toyota dot accelerate 88. And then maybe we should also have a function very fast here called print speed, or just, yeah, print speed. And that just counts current speed. Yeah, okay. Okay, so let me just call the function. There we go. Current speed is 0. That's not a good thing. I don't think it was supposed to happen actually, because current speed plus speed is greater than top speed. Maybe I don't think I need parentheses here. No, this should have worked. Let's try that again. Maybe I missed something. Toyota print speed. So Toyota dot accelerate. Oh. Else speed gets current speed gets speed. Oh, I guess I can use plus equals. Forgot to actually add the acceleration once you get there. So yeah, there we go. Why is it not working now? Let's see. If current speed plus speed is greater than top speed, current speed is just going to get top speed. Oh, we never initialized top speed. That's why. Yeah, so because we never initialized it, it's always setting it to 0. Because that's probably what it just happened to be initialized with by accident. So let's go ahead and make that part of the constructor. We'll make that be an integer. There we go. Okay, so now it'll actually let us. This will be good. I'm actually glad that I have that parameter in the constructor because I can show you that with the inheritance. So there we go. Current speed is 55 because that was the top speed was less than 88. But if we were to make the top speed something like 140 miles per hour, then accident. This would say 88 because that. But then if we add to the 88, maybe let's add in 50, 60. Let's add in 60 miles to that. In this case, now we're at 140 because now 88 plus 60 is going to be over 140, which the governor kicks in. If we bring this down to something like 50, though, we can see that it's 138. So that's the governor hasn't kicked in yet. Okay, so it's not the most elegant program, but it is a program, right? Okay, so now let's go ahead and first of all, let me compress the code so that I don't cut up the code by accident because I don't have you guys here to kind of give me a heads up on that. So I want to make sure I don't do that. So we're just going to make the code really ugly for now. And then maybe put these all in the same line. Okay. Good. So all we did was remove a bunch of spaces. But as you can see, the code will do the same thing still. Okay. So now what I want to do is I want to create... See, I really like this car. I like the way I set this up, you know? And like maybe now I want to make an electric car that has the same stuff as this, but has like extra functionality like battery life, okay? That's all I really want to add for the electric car. Maybe just battery life. So option 1 would be to copy and paste this and then just replace the name of the class and then basically just call it a day. But the problem is, suppose I find a glitch in some of my code in the accelerate function. Or maybe I no longer want to allow, maybe I do want to allow negative speeds in here and I want to change this. Then I got to change it in both spots in the code. And that's bad because that opens itself to glitches because like if a different developer is in charge of updating that, he may not realize that you copy pasted code. And now you're going to end up with problems, right? So what I really want to do is I want to make a reference to this and say, I'm going to make a new class that is basically the same thing as this class plus more. And that's exactly what inheritance will do. So I'm going to create a class. I'm going to call this electric car. And what I'm going to do is I'm going to inherit the car class by putting a colon and then putting a modifier such as public, private, or protected, which again, we'll talk about what that entails in terms of inheritance in a minute here. But doing that will basically allow us to inherit all of the features of car into electric car. And now if I just left it like this, then basically electric car is just sort of a nickname for car. Because I can do the exact same thing I did here, I could do the same thing here. I could make another object, but this one called electric car, and then maybe we'll call this one Tesla. However, it's not really an electric car because we are basically just making the same class twice. What did I run into issues here? No matching function for electric car. Oh, I see. So it's complaining about this because we don't have a constructor for it. So yeah, if I do this, oh well, now it's complaining for that. Yeah, okay, great. So this actually will bring up an actual issue here. Okay, so technically speaking, this would work if it wasn't because I have this constructor here. Okay, if I take that out, then this will work just fine. In fact, here, let me just comment that out for a minute and then remove this. This is, of course, going to mess other functions up, but it'll at least compile, I think. Maybe not. Why didn't it compile this time? No matching function call for electric car and Tesla. Oh, I didn't remove enough from the bottom. Oops. There we go. Okay. There we go. Now it compiles. Okay. It's going to give us zeros, but that's fine. So if in this case where I have a default constructor and I don't have any parameters in there, then technically this is just a copy of this class, just with a different name. Just Same stuff packaged differently, basically, okay? But as you can see, we are running into issues when we don't have a default constructor, right? We're actually getting errors because now this is looking for a constructor for this class. And so I could do that. I can just make a constructor for this class. And you probably will want to make a new constructor for an inherited class. And then this one doesn't have to have a parameter. But I do need to make sure that I call the constructor of the parent class with a parameter because it requires it. So how do I do that? Well, remember how I was saying earlier with the other example here that this is one way to initialize variables, but also very useful for other things? Well, that other thing has just come now. We can call constructors of parent classes here and pass parameters as required. So let's just hardcode one for now. In this case, just put the name of the class, not a variable or a specific object name, and then put in whatever you want. So let's just hardcode and say that all Teslas can only go 100 miles per hour. And so now this will compile and run fine, I hope. It's private. Oh, I see. I forgot to put the word public. Never make your constructors private. That just breaks things. There we go. Okay. So there you go. So now we got a Tesla, and we have a Toyota. So let me actually, I never changed this for any of them, but trust me when I say it would have worked, because it would have. But if I change them all, you will see that because the top speed is 100, this will print out first, I think 88, and then it will print out 100. So, oh, we never print out the further one, but you can see that the current speed is 100 because it's the governor, right? So when you're creating an inherited class, you again put the colon, and then you put a modifier, public, protected, or private. We will talk more about that later. Then you put the name of the class that you're basically inheriting from. And so now you got all the stuff from here is now here, like it just gets thrown in there, okay? However, the way that this actually gets allocated is when you have to create an object of electric car, it starts this constructor, and I could show you by running a debugger. I did that in the summer if you want to check out those videos. And then it goes in this constructor, and then before it runs the entire constructor, like this part, it just runs this part, and then runs the constructor of the parent class, initializes the entire parent class, and then finishes running the constructor of the derived class. That's important and by design, so that if you're referencing in here any of the variables from up here, they have already been initialized by the constructor of the parent class, okay? So that's very, very important. Let me say it one more time. When you create an object of a class that is derived from another class, what happens is, so like when you see electric car Tesla here, it runs the constructor of the electric car class. So this one, it only runs the first part. So like if you have default parameters, it checks if they need to be set to the default or if they're being passed in. Then it goes sees the colon, then it runs the constructor. Even if you didn't have this in here, it will still run the constructor of the parent class. It runs that entire constructor, does whatever it needs to do, comes back, and then finishes running this constructor. Again, this is by design, and so things don't break down. Okay? Because now, in this constructor, I can maybe want to modify some of the things from up here. So maybe I want to make all the Tesla's tire count to always be 4. So I can do that here. And this is modifying this tire count here. And so, you know, if this was dynamically allocated, which we'll talk about later on, it's important that it was already dynamically allocated here, so I don't run into a problem here. So there's a very important reason as to why that has to happen, okay? But as you can see, this runs just fine. Of course, we don't really do anything with the tire count, but trust me when I say that it does change it. Or otherwise, you can just run this code on your own and test it. But yes, but in this case, you know, we do want to have the ability to set the Tesla speed just like we did before, so that we can do something like here. And so to do that, what we can do is we can go ahead and create an integer here for the s again. This time, how about we set it to have a default parameter, like s is equal to 140 by default, or maybe not 140, maybe 120 by default. So now, in this case, to not hard code this, we can pass that parameter, as I was saying, to cart. So now, when this runs, you're going to have the 120 here, and then it's going to check to see if S has passed anything. In this case, we passed the 150, so it doesn't replace it at 120. But if we didn't pass anything, if we just had Tesla, just like electric car, here, we can actually deal with a different car. So I believe BMWs are electric too nowadays. Some of them are. So we'll say BMW. Okay, so in this case, this electric car, if we were ahead and say BMW print you know, accelerated maybe. Why is it not letting me? Oh, I suppose it with 2 W's there. Dot accelerate maybe 200. So now we go ahead and print the current speed. Then it'll default to the 120. As you can see there. And so essentially this is a very nice and convenient way of using default parameters and also passing that parameter to the parent class constructor. Okay? So anyways, the cool thing here about this is that, as you can see, I can call the functions of the parent class just like if they were part of this class. No difference. And that's super, super cool because now I basically have all of the stuff that I coded already plus more, which in this case, we're going to go ahead and say that this has battery, right? Battery, how about we say amps, right? Because that's what it measured in, amps, if I remember correctly. I think Teslas would be in amps, not milliamps, obviously. But yeah, so we'll say the amps. So how much juice the battery has, basically, okay? So, you know, if I charge my battery, of course, it would be nice to write a function called charge, but right now I'm just going to say I'm charging it by adding in 50 amps. Or maybe we should do it in gigawatts, because that's what like the DeLorean is, right? 9.8 gigawatts to travel in time. So, yeah. But anyways, essentially, I can go ahead and do that. And I can't do that with an object of the car class. So if I was to say Toyota amps, it doesn't even show me in the autocomplete. Now that is an error because it doesn't exist then. So you get best of both worlds. You have everything from this class up here, but you're not messing with this class. So you can still have, you know, regular internal combustion engine cars, but now we also have our electric cars. And I could even have a second class here that is derived from electric car that maybe I call it like Cybertruck or something. We'll say this is a Cybertruck from electric car. So now I'm doing basically inheritance in 2 levels. This is like the grandchild class. This one, again, is a constructor. So we'll say Cybertruck initializes electric car. Actually, just to prove a point, we won't even put a constructor because this one we're okay. Because what's going to happen is it's going to call the default constructor here, which will make S be 120, and then this will be called 120. So yeah, we don't need that. So maybe the only thing that the Cybertruck has is it has a load bed capacity. You know, because I think there's like a back part of it that can carry stuff, or I think it can carry like a jet ski or something. So we'll just say bed capacity, okay? So that's how much capacity it currently has available to fill with stuff. Maybe payload capacity. Payload available. Yeah. Kind of a rocket joke there as well, too. So now if I want to make a Cybertruck, we'll call this the C1. And then I go ahead and say C1, accelerate 110. Or maybe, yeah, 110. Because the limit is 120. Well, here, to show you the limit up to 130. And then if I do C1.print speed, that should give 120. I can also do C1. Payload available gets, I don't know, 100, and I can also charge it up. Okay. And don't forget this semicolon here, which is why the autocomplete wasn't working for the payload one. I forgot to make the thing public. And there you go. Obviously, we're not seeing any of the amp stuff because we don't have a print function for it. But that's the other thing. Supposedly, we wanted to update like print speed for some reason. I mean, there's no purpose to do it here, but just to give you a point, you can update functions. You know, so if you want to update a function, you can just override it basically. Override is the right term. So I can say, because the Cybertruck is cool, instead of saying current speed is equal to this, you know, instead of saying this, maybe it just says very fast. Like, I don't know why, but it just does that. You know? Big memes. In this case, it's just going to say current speed very fast. But what if we wanted to say very fast and then we wanted to actually print out the speed? Something interesting is going to happen here. This is the reason I'm actually doing this, not just for the meme. I run this, and guess what's going to happen? I'm going to get an error saying that current speed is private within this context. And you're like, wait a second. Why can't I access this guy? Because, I mean, this is a class, and I'm inheriting from that class. So, like, I should be able to access this class. Like, why can't I access current speed? You know, like, I want a refund on my current speed class, right? That's basically what I'm saying with this. And so, it turns out that this is where public, private, and protected are going to come into play here. Because here's the thing. Here's the rub. Yes, you inherited all of this stuff. Yes, there's a current speed here. There's a current speed in this one too. We even proved it because we were messing around with the max limit. But guess what? Because this is private, you can't access private variables directly in the derived classes. You can only access them in the parent class. So, oh, you may not have seen this bottom part of the code yet, but oh snap. When I was scrolling down. Well, if you didn't, that's okay. I was just calling accelerate of the Cybertruck. But yeah, going back to this, here's the thing. Current speed does exist in Cybertruck because Cybertruck is a child of electric car, and electric car is a child of regular car. So I guarantee you that it's there. We even modified it, as I said here, so that it was limited to something. And when you accelerate it, it actually updates. And print speed can call it because it's calling it in this class. Like the print function is in the car class, which can access any of its private variables. But guess what? Private variables are only accessible by that class's functions. When you derive a class and that class has private variables, the derived class cannot access the private variables. It cannot. And that is why we can't access the current speed from the derived class. And so now you should be thinking to yourself, oh great, I thought you said that this was literally just an expansion of the other class and we could like do everything we wanted. Now you basically scammed us. Well, not quite, because there's a very easy solution for this. And that is where protected comes into play. All I gotta do to fix that problem is turn this from private to protected. And now, if I go ahead and rerun this, it works just fine. And now my current speed thing can actually, I can update the function and still access those variables. And this is not just related to the fact that I'm overloading the function. If I wrote any function here, say I wanted to do a function that said like change color, okay? This function would work as it is now, you know, because if I do something like string s here, and then I just say color gets s, this would work just fine. I could go ahead and actually access the color parameter because it's public, and public variables are accessible anywhere. Like as long as you have access to the object that you're dealing with, you can access them. So this one's perfectly fine because it's public. But if color was private, you know, if I went ahead and moved the color like down here, or maybe just up here, since by default everything is private in the class, so now it's private, I would run into the same problem. It would say that color is private, right? So for this to work, again, I'd have to use protected. So let us talk now about public versus protected versus private, okay? So let's switch back to the iPad for that. So to clarify and to make sure we understand, we're going to do our little chart here, okay? And this is going to be called the accessibility of a variable or function in a, I don't know, would you say of a variable or function? Accessibility of a class variable or function. Yeah, that's a good one. Accessibility of a class variable or function in a program. So what this means is that if I have a class A, and in here I have a variable or function, you know, in this case just an int x, but I could have maybe a foo function or whatever. Where is this accessible from? First of all, if I have it just like this, that's the equivalent of putting the word private here. Just like with a struct, if this was a struct instead of a class, so if this said struct here, that'd be the same thing. But if I took this out, then it would be the same thing as putting the word public here. Okay, that's again the only difference between a class or a struct. But it's better to be explicit, so we either put public or private, or I suppose the third case, which now we just learned about, which is protected. Okay? So, how do these affect it? Let me first just tell it to you, and then I'll draw the chart. How about that? So a public variable, it's accessible anywhere. You can access it inside the class. You can access it outside the class. So like, you know, in main or whatever, if you have access to the specific object, you can do something like a dot, and then whatever the variable name is, or the function. Protected, for all intents and purposes, works the same way as private. If you're not doing inheritance at all, in any way or form, then it works the same. That's all you do. The only difference comes in between protected and private when you're dealing with inheritance. When you're not dealing with inheritance, where you're just dealing with just a classes in your program, protected and private are the same thing, okay? So, let's put it in the chart now. So in our chart, we're gonna have a 9x9 sort of chart. And you can find some equivalent of this chart in a lot of places on the internet. So, yeah. And it's going to be kind of a yes or no chart. Okay? So we have the three modifiers we're talking about: public, protected, and private. Okay? And accident. And then what each of these columns is, where it's available. So the first one is outside the class, such as in main or a random function. So like if you're doing something like a dot, and then you put the variable, so like a dot x. The other is going to be inside the class. That's like if you have a function such as a setter or the getter, and then inside of that you're dealing with it. So like if inside the class there's a function foo, then you just say something like x equals and then blah. You don't even need to put the object name because you're already dealing inside with an object. Technically speaking, that's the same thing as using a disk pointer, which we haven't talked about. But don't worry too much about that yet. Finally, the third category is what we're kind of facing right now with inheritance, which is inside of a derived class. Feel free to replace the word derive with any of the other terms that we use, such as child class or subclass. Okay? So that brings us into our chart. So let's fill it up with yes or no's. Is a public variable accessible outside the class? The answer is yes. You can access it anywhere. So in main or whatever. Is it accessible inside the class like this? The answer is yes, of course, it is. Is a public variable accessible inside of the right class? Yes, it is. We showed you the case. So here, let's quickly switch back to the code and show you the examples of that. So with the color, you know, if it was a public variable right before, we were able to access it here, right? So we can switch this back over to the public area, or we could just make this word public. Yeah, let's do that. Just to show a point that you can repeat them as many times as you want. Obviously, this is kind of messy to do that, but whatever. The code compiles and runs. So it is accessible to the derived class. You can also go ahead and say something like c1.color gets green, and it will compile and run. And of course, inside the constructor, I can go ahead and say, because it's a class function, I could say something like color gets gray by default. So that proves to you that a public variable is accessible in all three scenarios. Let's skip private. I'm sorry, let's skip protected and go to private. Okay? Where is private available? Is it available outside the class? No, it's not. You're going to get an error. Is it available inside the class? Yes, it is. It is indeed. Finally, is it available inside of a derived class? No, it's not, which is the error we're running into. So let's confirm those three cases. So inside the class, let's go ahead and switch the color to private. Here it's inside the class. And then here's the example of inside of a derived class. And then here's the example of just outside any of the classes. So let's compile and see the errors that we get. So we get an error from line 35, or sorry, line 6. No, sorry. Yeah, is that line 6? String is private within this context. So line 35. So we are getting an error in this line of code, line 35 right here. You can just not see the numbers of the lines there. Let me move that a second. There you go, line 35, okay? So as you can see, this is line 35 right here. So that is giving us the error. It's saying that it's private within this context. So this is the derived class, and as you can see, we cannot access a private variable in a derived class. The other error we're getting is in line 50, which is where we're accessing outside of the class. It says it's private as well. So that confirms that a private variable is only accessible inside the class and not outside and not inside of a derived class. Finally, we get into the protected. The protected one, like I said, works just like a private when it comes to outside the class, which means that you're basically just going to copy that up here. So it is not accessible outside the class. Inside the class, it works just the same way as a private variable. You can access it. So really, for all intents and purposes, private and protected are the same thing when you're just dealing with a single class. The change is going to be right here. This is the magic square. This is the square that changes things, because this is the square that deals with inheritance and how that plays into it. And of course, this is this, I'm trying to color it, but I'm having a hard time coloring it. There we go. That kind of worked out better. This square turns out that it's a resoundingly yes. You can access a protected variable inside of a derived class. And so let's go ahead and just confirm that. Let's go ahead and switch this to protected. I like this example because I can just have to change that one line of code. Let me clear it out so you can see the errors easier. So we're only getting one error this time. We're not getting an error from this one where we're accessing it in the same class. Notice that we're not getting an error with the change color in the derived class, which is great. That's what we're trying to solve. We are still getting an error in the access of the protected variable. So you can see here, protected, in the public setting here, where we're accessing outside the class. That's good, because we don't want protected variables to be accessible outside the class, just like we don't want private variables. And there you go. So now you have it, a situation where protected variables allows you to maintain sort of the privacy of the variable, but still have the advantage of inheritance. So that's where protected is going to come into play and be very useful, where you want to have the same protection as a private, but you still want to be able to inherit it and modify it in your inherited classes. Okay, that's very, very important. That's the power of protected, public, and private. Finally, the last thing I want to talk about with inheritance is let's go back and talk about the modifiers here. So we've talked about the modifiers in front of the variables, but notice that I am also putting the public modifier in the inheritance itself. And so what is that? You will, like 99% of the time, at least in this class, you will see me use the word public in front of that inheritance. But you could put protected, and you could also put private. In fact, by default, the inheritance is private. So if you just say electric car, and then you say just car here like that, that is the same thing as if I put the word private there. Okay? So what does that do? Well, I want you to think of it as a sort of a security setting. When you normally inherit variables, whether those variables are public, protected, or private, if you want them to remain with the same sort of layer of security, so if you want publics to remain public, you want protected to remain protected, and you want privates to remain private, you can just inherit publicly. And what that's going to do is it's going to keep everything the same. To think of it, what I like to think of it is it can only make it more secure, but it cannot make it less secure. So when you see the word public, it might be misleading to think that the protected variable is all of a sudden going to magically become public because you inherit it publicly, or private variables are going to now become public. That is not correct. They will remain private or protected. It's only saying the stuff that was public should remain public. So suppose that I did an inheritance, but instead it said it protected there. So suppose that I put the word protected here. What is this going to do? In fact, here, let's do that example maybe in the Cybertruck. If I do this, what's going to happen is private variables are still going to be private. Protected variables are still going to be protected. Public variables, however, which in this case are the top speed and tire count, those are going to be converted into protected variables. So they will be converted. So again, it's not making it less secure, it's making it more secure. It's not making privates into protected, it's making publics into protected. So, you know, the reason why it's very rare to see protected being used here or private is because you typically want to keep things that are public here still public. Like there should be no reason as to why you want to make them all of a sudden protected, because otherwise you should have done it in the original class, right? Again, you think of inheritance and sort of extending a class, you want to keep the same functionality, such as if something is public, like if functions are public, because this is not just going to affect variables, it's going to affect functions. So like if I all of a sudden say protected here, it means that all of these functions are now protected, which means that the Cybertruck accelerate and print speed are not going to work, because now those are protected functions and not public functions that I can call. So that's going to give errors here. But accelerate is inaccessible and amps is inaccessible, because both the accelerate from this function you can't no longer access because now it's no longer public, it's protected. And then the amps here that was public is now also protected, which means that I can't access it from main. And so that is why protected is not typically used here. Private, of course, will make it even worse, because that is going to, again, basically make amps inaccessible outside the class. And then furthermore, you can't change anything. Like at this point, you can't change anything from this class in here, because current speed, you know, we made it protected so we can inherit it. But by making it private here, it's as if we had made this private, so which means we can't access it. So that, of course, is really bad, because now the whole thing will not work. It's inaccessible to call this function here. And so essentially, you know, the public, private, and protected are mostly used there just to, in the case that you for some reason wanted to inherit and convert things that are public into like protected or private. But otherwise, you really wouldn't use it. Okay? So, yeah, that's pretty much that. Okay? As you can see here, all the functions are basically rejecting. Car is not an accessible base of Cybertruck and all of these things. Because what this means is that because it's private, you're not allowed to access it. So most of the time, you will probably use public here. But remember, I will emphasize this one more time. This is not making your protected or private variables public. It's merely saying, keep the status quo. Keep things private. Protected things stay protected. Private things stay private. And then public things stay public. It's only when you put there protected that you're making things from public to protected. But you're still keeping privates private. And then when you put private there, or you just don't put anything, which is the equivalent of putting the word private, that's when you just basically turn everything private, like even publics and protectors, okay? So you will again see me, you typically use public there. So at this point, I think I've gone already past the time limit of the class. So I think I'll just keep going, and then this will be also Wednesday's lecture, because it's kind of important to keep all this together and not just split the thought. So this kind of worked out great that we could do this. So I'll just keep going, and it's still I highly doubt this is going to go to 2.5 hours long. But in the case that you're watching it tomorrow, if you don't want to watch it in one go because you had a class to attend, just put a pause and just literally pick up from there the next class. Okay? So yes. Otherwise, we'll just keep going. We're almost done with this stuff. What remains to talk about is going to be multiple inheritance, and that's it, pretty much. Because as you can see here, well, aggregation as well. Okay, so actually, yeah, there's some multiple inheritance next. Okay, so let me go ahead. I wasn't expecting to have this many codes. So let me make another file here. We'll call this one mult int. So it stands for multiple inheritance. So now we're gonna run into the some interesting issues here. All right, so you discovered inheritance today, and you fell in love with it so much that you're literally just like inheriting everything left and right, right? And it turns out you make these two classes that you really like a lot. You got this class mom, maybe lowercase. No, we'll do uppercase. And this class mom has a I function and maybe a hair color. We'll initialize this here to brown. Okay. And then you also have a class dad, and that has a bottom male. I'm trying to think of like a thing that would have that a mom would not have. That's not inappropriate to throw in here. Well, whatever. We'll just say that he has a watch. Okay. No, that's just random. Okay, whatever. We'll just say that the height. For some reason, the dad has a height, but the mom does not. Okay, it's strange. Whatever. It's the point I'm trying to make eventually with this. And then maybe we give him one more thing. So maybe, well, I suppose that this is kind of random, but technically speaking, he could have a different hair color of like the body hair, right? Because I think like chest hair. Yeah, chest hair color. That's kind of a typically associated to males, but I mean, not trying to make a statement of that, but you know, why not? We'll just throw in that. Okay. Don't forget to make them public so we don't get the compiler yelling at us. Okay. Yeah. So, okay. So we got class mom and dad, right? You really like both of these classes, like so much that you want to make a class that contains everything that mom and dad has. And we're going to call this the son class. Okay. And so the son class, you know, if you want to inherit from one of them, we already talked about that. You can say something like public mom. But now, what if you also want to inherit from more than one class? You can do that. And the way you do that is you put a comma, which I kind of put by default already, and then you put the second class. But make sure you always put the modifier that you want for each class. Because like you might naively think, okay, put public and then put all the classes, and you assume that they're all public, and this will compile. It will compile. I mean, well, as soon as I put a semicolon, it will compile. So if I say G++, you know, I'm getting a warning because I'm not compiling a C++11. But if I do that, then the warning will go away. So it will compile just fine. But it's wrong in what I'm trying to do, because this is actually making dad be private. Because again, when you don't put a modifier in front of a class that you're inheriting from, it defaults to private. So this is actually inheriting as private. So don't naively think this works. What you need to do is you need to put the word public, private, and protected in front of each modifier to be explicit about that. Okay, so now what we have is we have a son, and the son contains everything the mom and dad has, which means it has an I variable, has a height variable, has a hair color, has a chest hair color. I want to prove that to you by declaring an object of the son called Timmy. And Timmy has I color, which will set him to, I don't know. Well, here, I know. To make life easy, how about we initialize these? So it has green eyes here, and then the height, we'll just say it's in inches. So 60 inches. That's 5 feet, I think. Oh, well then I guess we should make him higher. 72 inches, right? 6 feet. Yeah, that's more like whatever. I mean, I'm sure there could be 5 feet people too, but I'm kind of basing it off myself because I'm 6 feet. So I was thinking 5 feet was a little short. But yeah, and then I guess just to make it different. Not that it really matters. We'll say blonde. Okay. And so now, if we go ahead and see out all of Timmy's features, I should have picked an easier name to pronounce. We would see that he contains, as you would expect, his mom's eyes and his dad's height. I'll just put these two for now. And of course, you could modify them. You know, you're not limited and say, you know, they have to be 72 in green. But we're just saying it contains them, okay? Semicolons. Valid conversion. Int I. I don't know what I was thinking when I said int I. I meant string I. And I have no, I don't know. It's late at night. That's probably why. So there we go. Timmy has green eyes and is 72 inches tall. Okay? Which makes sense because he inherited from both. And this is great. You know, I wouldn't recommend you think of it inheritance again like mom and dad, because really, again, this is saying that it's a reference to them. We're basically saying that Timmy is a mom, but is also a dad. And that's really the right way I want you to think of this. When you do inheritance, you think of that as an is a property. So we are saying Timmy is a mom. Timmy is a dad. Not that like he got this from his mom or he got this from a dad. It's a much better way of thinking about inheritance. Okay, especially when we talk about aggregation in a minute here. So it's a relationship. This is where the issue comes. Let us go ahead and say that the mom class now has a height associated. And we'll say that the mom is 71 inches. Or 73 inches, you know. She's like a tall person. Okay? So, in this case, we have a bit of an issue here. You know? Because now, Timmy height has a problem. Whose height are we talking about? Is it the mom's height? Or is it the dad's height? You know? Especially when it is being initialized here, it's already running into issues. Because like, it's like, should we initialize this to 72, to 73? Like, what do we do? Like, we have two variables of the same name in the class. We have a mom height and a dad height. And he basically inherited two different heights. And now his body's like, how tall should I be, kind of thing. Let me give you the short-term solution for this. One of the ways that you can solve this, I believe you can solve it this way, is you can put the class name in front of it. Timmy's not a member of mom. Oh, I think maybe we put it here. I think that will fix it. Yeah, that'll fix it. So one of the ways that you can fix this unfortunate issue here is you can, when you have two variables of the same name that you're inheriting, because obviously, you know, if I try to have two variables height here, you know, like this would not compile. This would be like, yo, you have two variables of the same name. You can't do that. Previous, you know, redeclaration of a variable. However, when you're inheriting, you can run into that situation. And the code will compile, so you won't know that the issue is happening at that point. I mean, this part will compile. This will, of course, give you an error as it did before. And that's because you technically have two heights. You have the mom height, and you have the dad height. And so now, to prove to you that there's literally two variables called height in here, I'm gonna go ahead and say mom and dad like that. And you can see that we have two variables called height and they both contain different values. And worst case, you can't just say Timmy height. Like Timmy no longer just has a height. You can't say Timmy.height because as you saw, that doesn't compile because it's ambiguous to the compiler. It's like, whose height are you talking about? The mom height or the dad height? And so the short-term solution, I suppose, is like what I did. After the dot, you put the name of the class that you're referring to with the scope resolution operator, and then you put the variable name. And then you solve the ambiguity problem, because now you're like, I'm talking about the mom height part, not the dad height part. And then you, I mean, not only can you access the variables, but you can actually modify them. So like I could modify one of the variables and it would not modify the other one. He shrank, you know. Or, yeah. Oh, it's because of this still here. Let me get rid of that. So as you can see, you know, the mom side of it is 55 now, but the dad side is 72. So he still has two heights. So this is one issue that we can have, you know, that can have with programming. And this does a little bit relate to like biology, right? Like if you inherited two of the same like DNA, that could cause issues potentially, right? So your body just picks one or the other. Here, the compiler doesn't do that. It's like you get both copies, and like good luck with that kind of thing. This is one of the issues that you can have. The other issue you can have is what is known as the diamond problem. The diamond problem is kind of the same thing, but more accidental. Because like, let me give you a situation now. Let's say that we have a class called grandma. Okay? Grandma is going to be inherited by both mom and dad. And I hope you can see where this is going now. But then mom and dad basically inherit the son class. This again is known as the diamond problem and only happens in programming languages that allow multiple inheritance. Let's say, because in this case, what is shared between both classes that you could make in a common class would be the height, right? Because both of these variables have a height class. So I think a better name for this variable instead of grandma would be probably just like height, but we'll call it grandma to go again with this theme example here. So ideally we want to have this have the height in it. What did we say was this height? Like 72? And then that way, you know, we don't need to have a height in this one, and we don't need to have a height in this one, because we can just inherit it. Right? And so this will work just fine. I mean, we still have the ambiguity issue. Has the measurement height. Height, oh, int height. There we go. Okay, so we still have the same issue and we still have the same solution, but now we have a more of a practical situation that you might have. This was more accidental because here you didn't intentionally mean to have the same variable in two classes, but both of your classes are inheriting from the same class, which is perfectly fine at this level. This is fine. Your mom and your dad can have a height. That's okay. This is a better way of coding height, actually, instead of having the height be in both classes. The problem is when you do son, because son is getting the height from the mom and the dad because they both inherit it from here. So there's two copies of it. So that is a diamond problem. It's the same problem as before, but a different situation that arises. Whereas before we manually had two variables of the same type, here we are basically having the variables again, but only because of an inheritance issue. So in a way, you could think of this as inbreeding, kind of like programming inbreeding in a way, because son gets two copies of the grandma class, gets the copy from the mom and gets a copy from the dad. And that is why son has two heights associated to it. And yet again, what kind of solutions can we have? Well, you can solve the ambiguity problem of having two instances by referring to one of the two variables. Now you can't just say grandma here because there's two grandmas. You have to say the mom or the dad. Alternatively, one of the things that you can do is what is known as virtual inheritance. We haven't talked about virtual functions yet, but I will bring this up. So what you can do is you can add the word virtual, I believe, to both of the classes. And so now the code will work the same way, but this line of code will also work. 55. And as you can see, before, if I changed height of the mom to be like 57%, you know, and then we switch this back. Here, let me switch it back for a minute so I can show you the output before and after. So here you can clearly see that there's two variables. Get rid of this one too. You can see that there's clearly two variables, right? There's two heights, the mom and the dad's. They both inherited from the grandma, okay? But if I add this magical word of virtual, which you can add there, or you can add here, the order doesn't matter, it's kind of like the static thing. If I run it, compile and run it, you can see that both the mom and the dad are referring to the same height. So now we only have one height. What happens here is you're basically saying, yes, there's inbreeding going on because you got the mom and the dad who share the same parent. So you have two copies of the same parent, which is in your case the same grandparent. However, the virtual word comes to the rescue and says, hold on a second, do not associate each of the two copies from grandma. Instead, once you actually create son and you realize that you have two copies, you're only going to associate one copy. So you're only going to have one height variable. You can still, if you so deem so, refer to it as a mom height or dad height, but they will both refer to the same thing. And better yet, you can just also refer to it just like height. And now you don't have that ambiguity problem because they both refer to the same thing. And so that is the real solution to the diamond problem, essentially, in multiple inheritance. Again, we will talk more about virtual because this is an example of runtime binding versus compile time binding. We will talk more about virtual once we actually focus on talking about virtual functions and that kind of stuff. But I did want to already talk about this because you may run into a problem like this and now you know how to solve it. And you got to put in the virtual part at this level. Don't put it at this level or at this level because it won't work. It has to be at this layer, okay, at the middle layer of the diamond, okay? So hopefully this example did not offend anybody. But it's a good example. I think in the past I've taught it and people said that they really remember the inbreeding issue of this. So I thought I'd keep it until somebody yells at me and says it's not right. So whatever. So yes, that is the solution to this. And of course, this solves the problem of inheriting from grandma with a height. But if you do run into a situation where you're inheriting from two classes that do share the same variable, but it's not something they're sharing because they inherited, but because you actually have a variable. So like if you actually have a variable here called I, and it's not inherited, then that requires you should probably think about why that is happening and refactor your code or rewrite your code in ways that it shouldn't. But in the last case scenario, you can use the way that I did it here by putting the scope resolution operator as a sort of a nasty patch way of solving that issue. But hey, a solution is a solution, right? So yeah, that's part of the beauty of things. If it works, doesn't matter how you got there, it just works, right? So that's multiple inheritance and a little bit of introduction into virtuals, but again, we will visit virtuals more. Right now, this should seem like magic to you, and it kind of is, but we'll look more deeper into the magic at a later time. The last thing we want to talk about is composition or aggregation, okay? So there is another way of including things from a class in your other classes than inheritance. There's an alternate way. And that is through the usage of aggregation or composition. So let me go ahead and open one more file just to leave that example there. We'll call this one comp.cpp. And I will upload these later today since this is the full week lecture. That way you have them available. This kind of works out well because I had a meeting in the morning on Wednesday, so this actually works out. Okay, that's fine. That error is because I forgot to put the int main part. But yeah. Okay, so, you know, I have a class A. We'll call this class A. We'll call it class A. And it has an index. Okay? I have a class B that maybe inherits from class A publicly. I guess to prove a point, why don't we use the word struct in here? Now we don't have to use the word public. Because for all intents and purposes, it's the same thing. But it's a good thing to kind of, you know, throw it in once in a while. And this one has an int y in it. And so, finally, we have a class C. I keep uppercasing that. I do not know why. Okay? Class C, suppose that you wanted to have the x and the y from A and B. One of the ways that you can do it is with inherit. In this case, if I guess I just have to inherit B, and I would have both x and y. You know, if I inherit B from here, I can say public B, and now I have an x and a y, right? There is another way that I could have access to that data, or access to that sort of architecture. And that is by merely, suppose I want to have a variable z here, but I could also just simply have a variable b inside, called b. And so now, I have an object of b inside of c, and an object of b contains an x and a y in it. This is known as aggregation. And if I want to access it, it's a little bit different. Whereas when I have an object of b here, you know, I can access b.y, where I could access b.x, you know, because it's inherited. If I have z, an object of c, I can access c.x, because that's inside the class. But if I want to access the y that lives inside of this b here, I have to do c.b.y. Similarly, if I want to access c.b.x, I have to do it this way. Obviously, none of these are doing anything, but you know, wow, damn it, public. And this guy. Too much Python these days. There you go. So that is how I access it. Now, obviously, nothing is printed because I'm not inserting anything or couting it or whatever, but you can do that on your own time. This is a different way of accessing the data than this way. Both allow you to have essentially a B inside of your C, but one of them is using inheritance in the case of like B having the X, and then one of them is using what is known as composition or aggregation. As I said, inheritance is what is known as a relationship. So like B is an A. That we would say that because B is basically containing everything from A, and it has it as part of it. So we're saying B is an A. C, on the other side, has an object of B. So it's a has a relationship. So let's just go ahead and write that down to emphasize it on the tablet. When we are talking about inheritance, we call it a is a relationship. On the other hand, when we're talking about this new method, which is known as composition or aggregation, these terms do mean other things in other scenarios, but in this specific class, that's what we're naming them as, is a has a relationship. Maybe I'll shrink this a little bit. That way I can fit it all in one line. The E came out weird. Okay, so composition or aggregation. Maybe I should spell aggregation slower. Aggregation. Okay, there, looks a little bit nicer now. has a relationship. So when you're trying to decide which method you should use, think about it this way. Think about, let's go back to maybe the electric car example. This one, yeah. So we're saying, is an electric car, does an electric car have a car in it, or is an electric car a car? So like, electric car is a car, or electric car has a car? And the answer is, electric car is a car. It's just a different kind of car, but it's a car. It's not that electric car has a car inside of it. That would be wrong to think about that way. So it's also a good sort of tongue twister to check whether something should be inherited or aggregated, basically. Going to the son. Son is a mom, son is a dad. Son does not have a mom, and son does not have a dad inside of them. Doesn't. That would be weird and creepier. So essentially, when we're trying to decide which of to use, think about that. A good example is this. If your object C requires more than one instance of a class, so like let's say you need to make an array of objects of B, you definitely want to use aggregation. So you can make an array of B's by saying something like 20. Okay, so now I have an array of 20 B's inside of C. So this means that now I want to access a specific instance of them, like instance of like B0 and B1, for example. Well, let's make them all do the same thing, okay? And that will compile and run. So if I need to make a lot of them, you definitely go with aggregation, because with inheritance you can't, I mean, other than like problematic stuff like having two heights in there, which you don't want, that kind of thing, that's not the way to do it, to have multiple instances of same data. If you need to have like here a lot of something of an object, like an array of them, a vector of them or something like that, then you definitely want to use aggregation like this. Okay? If you just need one copy of it, and if it should be something that it's kind of like extending on the previous one, that's when you're going to do inheritance. So B is really extending A. It's, you know, it's expanding it. It's the DLC version of it. On the other hand, with C, you know, it has a bunch of B's in it. It has them. It's a feature that it has, but it's not what defines the class. In both scenarios, if I modify B or A, it's going to change C because it contains B, and if it inherited it, it would still affect it. So I guess by example, if I change A, so if I add, for example, a W to A, that means that B now has a W in it, and that means that the objects of B inside of C have a W in them, but C itself doesn't have a W in them. So if I want to access them here, then I would say something like C dot B0 dot W. Okay, so that's an important thing to understand as to when to choose one or the other. Also notice how you use the array access operator. So because you have an object inside another object, so like object inception, you keep using the dot. So like suppose that B, this is not a good idea to mix it. In fact, I don't even want to mix it because that'll confuse, for example. But let's say that we have another class called class X, and class X has a variable X in it. Okay. Semicolon, and then why is that? Oh, that's why. Suppose that we wanted B to have a class X in it, because there's something like XX. I mean, you could also call it like Y, but that would be super confusing. Well, not Y, but W. But we'll call it like X. Okay. In this case, if I wanted to access the X inside of class X, I could say something like, well, let's say if it was part of B, I could say like B dot X dot X. And so what this is doing is, this is saying B's X, which is this one here, this object, and then I'm accessing that object to access the inside X, which is this one. So that is the same thing as modifying this variable here. Let's try with C. So C dot B, and let's say we're accessing like the second element there, and then we want to access the X inside of that. So we say X, and then the X inside of that. So what that is doing is that is accessing C's B array. Then the B array contains 20 of these, and we're accessing the first one, or the second one technically, because array starts from 0. And then from there, we are accessing the X object there. And inside of that, we're accessing the X local class integer there, which is that. So as you can see, if you have objects instead of other objects, you just add a bunch of dots. And you could potentially have a chain of like 5 dots, you know, if it's inside. With inheritance, you don't need to do that. With inheritance, everything is like the top layer. So like this way, you know, B has a Y and B has an X. The Y is coming from here and the X is coming from here. Everything is accessible with 1 dot. But with aggregation, you have to add the different dots. And that's by design, so it's good. Okay? That is basically inheritance and composition for you. And there are both ways that you can basically expand upon your classes to add more code, basically, to your programs without having to rewrite things. And it's a very, very powerful feature of object-oriented programming, because with it you can basically code something once, and then if you want to make it better, you don't have to rewrite the code, or you don't have to copy paste code. You just extend it with inheritance or with composition, depending on which you want to do. Remember, is a and has a relationship. Those are the ones that you need to think about. As a final thing, let's go back and revisit UML diagrams just to make sure that we understand them. With a UML diagram, remember that you have a class, and then you have your variables and functions, and we have the minus for private and the plus for protected. Typically, you will see something like a pound sign, or I think it's a pound sign, the most popular one, for protected. So that's something that you should be aware of. But when it comes to inheritance and aggregation or composition, you will see an arrow typically pointing to the parent class. So if there's any sort of inheritance, you will see the UML diagram for a class, and then you will see that if it's inherited from another class, you will see the one that it's pointing to. So you don't have to rewrite all of the different variables that are being inherited. You just put the arrow to the parent class, and then just add the new stuff that you're adding in this class. That's for inheritance. For composition, you just merely put the object name, and then just make sure you list somewhere else. Like, so if here there's a B, then make sure somewhere else there's a B classified so you can explain it. So that's mostly if you run into that on the assignments and things like that. So that pretty much concludes the introduction into object-oriented programming. So now you know what object-oriented programming is. You know a couple of the most important concepts of object-oriented programming, which are encapsulation. Here, let me write them down for you. So we got encapsulation. We also have inheritance. That's the other important concept of programming, of object-oriented programming. And then you have polymorphism. So these are like the key parts of what object-oriented programming is. Encapsulation is the idea of putting things in capsules or buckets, like we said. So basically taking your data and operations on that data and putting it all together into like a nice little pill. Inheritance is the power of how you can extend things and take code and basically expand upon it. And along with inheritance, we also have composition, which is another way of basically extending code. Polymorphism, which means multiple forms or shapes, we haven't talked about too much in detail, so this we will revisit. But to be able to revisit that, first we have to understand how dynamic memory works so that we can do pointers, so that then we can learn about up and down casting and virtual functions, and from there we will basically be able to come back and really analyze the last part of object-oriented programming. But even now, we know a little bit of polymorphism because we know function overloading with all the parameters, and that's it's kind of a form of compile time polymorphism, really. Yeah, pretty much. So we do know a little bit of it, but we will definitely revisit this very big word in programming, in object-oriented programming, known as polymorphism. But like I said, we have to learn about dynamic memory and pointers before we can understand this. So starting next week, I suppose, we are going to switch gears, and we are going to start talking about pointers and memory, dynamic memory allocation, and learn that concept. So a bit of a switching of gears into like, we shall say phase 2, and it's pretty early on, I would say. Technically speaking, it's just the second week of actual full class, I suppose. Or is it the second or third week? Actually, technically it's the third week. It'll be the third week by then. This is the 4th lecture, but the 5th class. So yeah, and then this is because this one's a 3-hour video, but it's basically the full week's lecture. But yeah, so essentially, we're moving along, and more assignments coming up, and things are gonna start to ramp up. Pointers is a hard topic, but it's one that I do my best to cover. So look forward to the next video when we shall enter the world of pointers. So that is it. Just very briefly take a look at my notes, make sure there's nothing else that I want to mention. This is the time when I'd ask you for questions, but no worries. We will have light class next time, so we'll be back together on Monday. Or if you're watching on YouTube on Tuesday. But yeah, and if you want reinforcement on this stuff, I also have the summer videos you can watch. Those are the first 4 videos is basically what we've covered so far. Video 4 would be this stuff actually. So yeah, it's almost identical, I'm gonna guess. I did an example with animals in the summer, so if you want to watch that, you can. But yeah, so well, if you have any questions, please send me a message on Canvas or email or Discord, and I will do my best to help you. I've been helping a lot of people out that have been messaging me, and I'll continue doing that. It is my pleasure to answer your questions, guys. I do find some form of entertainment in doing so. Since I'm basically stuck home, quarantine and everything, I do enjoy actually, answering you guys and helping you out, because it's a form of social interaction. So I am very happy to answer you guys. So please, you're always welcome to ask me questions. Hopefully these examples were good, and I hope that I was clear, and hopefully I didn't cut off too much code when I was trying to type the code. But in the case that I did, the code is available on Canvas, so you can check it out. But yeah, that's pretty much it. So until next time, thank you for watching. Don't forget to like, comment, and subscribe. And I'll see you guys next time. Take care and have a lovely day. Peace out.